So, without much ado, this is the class on smart contracts and why are they important. And I'm going to welcome Isaac to present himself and start the class.
Hey everyone, I'm excited to share stuff about this. So I've been a smart contract developer for over 4 or 5 years now, experimenting with a lot of stuff, both in the identity space, the DAO space, DAO frameworks, but also experimenting a lot with like different things you can do with NFT projects, and really where you can take the creativity and the imagination of what a lot of people are thinking about with regards to like interactivity and NFTs, and making that a reality. And I also just enjoy helping people kind of understand how to kind of look underneath the hood of these projects, so that you can figure out what they say the project does versus like really being able to validate that for yourself, and understanding maybe any of the fun ways that it's been implemented, or ways that you can kind of take code and fork it and add your own features. So today I just wanted to kind of give an intro to the concept of like how smart contracts play into blockchains in general, but then more specifically NFTs and artistic creations. And then I had planned that we can also pull up just some smart contract code and start messing around with it together. And maybe if we have different ideas that will come up that maybe even thinking about over the course of your residency, like wouldn't it be cool if an NFT could do that? And then maybe we can take some of those ideas and just go through and try to make it work. So if that sounds good to everyone, I'll start with some slides, but yeah. Also, feel free to make yourself visible. Otherwise, I'm talking at a bunch of PFPs, which is fine. But I always like kind of seeing who I can talk to. Thank you. Thank you. Let's see. I'll share. All right. Can everyone see some slides? Great. So we'll just talk about some basics about how smart contracts play into like blockchains, which blockchains support them, which ones don't support them, how that applies to NFTs, and so on. So I like to think of you can kind of bucket blockchains into whether they kind of support this dynamic programmability or not, and so when you think of like these two main buckets, Bitcoin is an example for me of something that like it fulfills really one use case, which is the ability to like create new Bitcoin through mining, and then sending it and spending it and like aggregating it and sending it. And yes, you can like you can do some stuff like with like programming and adding additional functionality, but it's really kind of like hacking the system. It's not using the system as it was intended to be used. So Bitcoin's job is to make sure that people can earn and spend Bitcoin and secure the network. But then if we look at something like Ethereum or Solana or Tezos or Near or something, it's built into the core of the system that anybody can run their own code, that anybody can like deploy a system that other people can interact with. Early on in Ethereum, this often just meant creating a new token, so a new thing that kind of behaved like Bitcoin or behaved like Ethereum, but like it was my token for my community. And more recently, like people have been adding more and more governance features to stuff like that. But that's like probably the simplest smart contract you can do is like is create your own like fungible token, just like Ether or Bitcoin or something that you can use for spending. You can also deploy any arbitrary applications that run on it. So it could be a financial application, which is like, you know, an escrow service where you're like holding money between a like contractor and a company, and you can do like financial things easily. You could do non-financial things like creating a notary. Like, what does a notary really do is they kind of put their stamp on it and say, I saw this document at this point in time. I'm a trustworthy person because the government gave me a notary stamp. You could create a decentralized version of that very easily as a smart contract. So on these blockchains, there's like the fee structure is different. Often you're paying more fees when things are more computationally complex. Because you can think about like when you're using a complex smart contract, unlike Bitcoin, which all it's really doing is saying, hey, this Bitcoin was spent, this Bitcoin's not spent. On Ethereum, like you could have vast amounts of data, and if you deploy that to the network, you could fill up everybody's computers that are also on that network, and that's pretty expensive. Well, expensive for everybody, because you could think like, if I want to put my NFT on chain, it is going to get replicated on like thousands, maybe millions of people's hard drives around the world. And like that's really where the core of the fees come in, is like makes you really think, is this worth replicating on everybody's computer around the entire world? And if you think like, no, maybe I don't want to store a full like 5 megabyte image on chain because that's going to cost me $20,000. Maybe you can think of another clever way to construct that data, or maybe you can think like, oh, maybe I'll just store a reference to it on chain. And so like, that's an important thing about these programmable blockchains, is that you're going to be paying fees because things have to be replicated all around the world. So, like I said, you can use them for whatever you want. You can create escrow services. You can like fractionalize something where like you take one asset and you allow people to hold like a governance token about what to do with that asset. You can timestamp information. Typically, you can also like kind of decentralize like rent-seeking middlemen. If there's a business in Web 2 which is just based on somebody like having the attention span of other people and then extracting some fees, you can typically cut them out of that structure and create your own system. It doesn't always work, because like if that was 100% true and there was no value to the network, then like why do we pay OpenSea 2.5% on every trade? And the reason is like network effects are still a thing. Like like where the eyeballs are is still important. But you could replicate the functionality of something like OpenSea and just remove that fee. Like there's nothing stopping you from doing that. But you would just need to get the traction. Feel free to interrupt me also if you have questions. I just saw somebody unmiked, so maybe there was a question. There's things that our smart contracts are not great at. So blockchains know information about themselves. Like they know who has how much money, they know who has what tokens. They don't know things like the weather, or they don't know things like who won a sports match or something like that. Like anything that requires bridging non-blockchain native information in always creates kind of like a potential issue, and you have to have a complex structure around that. They're not great at storing lots of data, because like I was saying, when you store data on chain, you can literally think of it being replicated on thousands of other computers. It's like a really inefficient data backup. It's also not good at keeping things private, because like even though you can encrypt stuff, you can make things like private for specific people. There's unless you have some other system that's kind of doing that like privacy stuff, there's like things are very transparent. Like we've seen that recently with last week with like the government going after that transaction privacy service called Tornado. That was a service that was helping people keep things private, and just that alone was enough for them to be like, this is sanctioned. If you use this, you're getting banned from you're going to get banned from the financial system, and no one can interact with you. And so like you can kind of think of that and be like, okay, well, governments don't like this privacy tool. Clearly they're pretty okay with the fact that all other transactions on blockchains are like completely public. So NFTs are a good fit for smart contracts, because like most of the time they represent purely digital assets, or in some cases where there's like a crossover, where there's like a physical thing that can be redeemed or burned. Like they're quite good at like at least recording who still has the digital thing, but like they're not awesome for like physical backed things always, because there's always a risk of like custody and who you're trusting, and then you have to like insure yourself against any risks that come from that. They're also handy. They're also a good fit for smart contracts because you can like decentralize the control of them. Like you can make it so that a community really is in charge of like, should we issue more NFTs? Like that is like you can give your like token holders that those rights. The most important thing is that like NFTs create this work because of a standard interface, like a website, a wallet, a marketplace. They all know how to represent an NFT because they all use a standard marketplace. They all use a standard interface, and like that interface really is the key thing that has allowed NFTs to scale. Because similar to before, I was talking about kind of like the network effects, of these systems. Like they all work because everybody that creates a new NFT project, the marketplace doesn't have to ask them, hey, do you want to put your NFT on our marketplace? They can just show it. And then you kind of have the opposite problem where then there's like a bunch of spam and you have to then kind of start filtering and hiding stuff. But the standardized interface makes it so that anybody could create an NFT marketplace and they don't have to ask people to put their stuff there. They can just like scan through the blockchain and see all the NFTs out there and render them. Let's see. Oh, cool. I see that there are a few questions. So I'll pause here and kind of go back through the questions. Unless somebody from like Mikol or Boria wants to moderate, because I'm not sure how far back to scroll.
Hey, Isaac. Just wanted to let you know that we actually have a chat. I don't know if you're able to see it. The way to open that should be on the top right corner. You're going to see like a bubble for a comic. And if you click on that, it's going to say show.
All right, I see a few. All right, so from Reverse Butcher, this is why some platforms use IPFS, because blockchains are not great at storing a lot of data. So it's part of the reason, I'd say, because like if you want to store like gigabytes full of data and you want to do it in a way where it's not able to be like censored by storing it just on like Amazon's platform, then IPFS is nice for that, because like you can it's like the community is hosting the data. So like what IPFS does is like it makes it so that if you view something, the next time somebody tries to view it, they might be getting it served from your computer, because like it creates this like decentralized mesh of people hosting files, rather than Amazon, where like I just create an Amazon account, I add my credit card, and then they'll store my stuff as long as I'm paying them. But as if I stop paying them or if I take it down, then it's gone for everyone. So do you know how or why the file size limits on IPFS? So IPFS, in my experiences, I've run up against issues when I've tried to upload things larger than like 30, 40 gigs of size, like a big folder like that. But so the network itself has some constraints, but then the platforms also have some constraints. Because like if I go to, I don't know, if I'll go to like Rarible and like look for just anything. Wonder if I can get in without they make me accept the terms of service whenever I join. And I can't do that because that's a ledger. There we go. So they let's just pick like anything. So I can hit this refresh button, and what this is doing is it's like calling out to the network and checking to see if the data is updated. It happens the first time automatically when a new NFT gets minted. Their system like goes through and crawls it. If when I hit this refresh button, I was asking it to pull down like, I don't know, a file the size of like a gigabyte or something, Rarible, like, and if everybody did that, Rarible's website would just slow to a crawl and just not work. So they are going to have some things where it's like, if this takes longer than 5 seconds to fetch, we're just not going to display it. And for those things, you're going to have to probably email them and be like, hey, yeah, my image is really big, and they might say like, okay, sorry, like we just can't support that because if everybody's files were big, then our website just would crash. Um, so that's why the platforms themselves have some limits related to file sizes, uh, just because they wouldn't be able to index everything if everybody's data was big. All right, let's see. Yeah, so for when people say art, like on-chain art and like SVG art and stuff like that, you can do all sorts of, and I actually don't know the state of the art of this anymore. My data is probably a bit older, but if I like, actually nouns is a great example. So if I look at nouns, what is it? And if I go to the playground, I can just generate all these different SVG images. And like, but what does it actually mean for this data to be on chain? So if I go to the nouns code, let's see if I contract read. So let's get like the again, I'm gonna start like crawling around Etherscan. Let me know if it would be handy to just have like a general Etherscan primer. But like this is kind of how you look at what smart contracts are doing on chain. So if I go to the token URI, which is the thing that says like, okay, here I have an NFT, I want to know what it looks like. You go to the token URI. So if I look at token URI for token ID 101, let's see, why doesn't that work? Interesting. Owner of. That's actually pretty weird. I'm not sure why that is saying that it doesn't work. So the nouns token, if we try to get the token URI, because like token URI will revert if a token doesn't exist, but all of these tokens exist. So here's like, token ID 105. Might be an Etherscan bug. So that shouldn't be happening because like what this should return is like actual SVG data. Because if we look at like let's see if I can find the nouns descriptor contract. I have a link to it in another one of my presentations. This is actually an analysis I did of the nouns smart contracts. So they have this contract called descriptor, and we can look at, so we see accessories, bodies, glasses. So for every trait that you see on different nouns, they've actually had to generate those SVG files and upload those on chain. And then on chain, when you call token URI, it should like stitch all of those SVGs together into the image that you see. And so if I look at glasses, this is actually pretty interesting. So like I look at glasses and I want to look at glasses number 1. So what can we actually do with this? I think that, so they have like kind of a special like data encoding scheme, but I wonder if we can do hex to base 64. And then base 64 decode. So when you take data and actually store it on chain, it goes through like multiple layers of encoding, which is hard for humans to understand, but like the marketplaces all know how to do it. So I don't think I necessarily decoded everything properly, but like you can take this data right here, which I'm pointing to on my screen, is the data for all of these different like SVGs for all the different like nouns glasses. So whenever they want to create additional heads, bodies, backgrounds, they actually have to pay fees to do that. So if we look at some of their recent transactions, like add glasses, They added 21 different pairs of glasses, and that cost them 281,000 in gas. Because, like I was saying earlier, those glasses are now replicated on like every Ethereum node in the world. So like they were like, this is worth it enough to put these like glasses on chain. And that would be different from like another way that you could implement the noun system, which would be more centralized, is like every time a new noun gets created, you just like generate the PNG, upload it to Amazon or Pinata or something, and then say, oh, here's your new noun. But like one of the reasons people think nouns are interesting is because of this entire kind of like on-chain SVG construction. Other questions? So when you're doing things that are like 3D works and stuff, I had a friend that she generated her first render of this like 3D shirt that she created was like 160 megabytes, and she wanted to sell it on I don't remember, it was like super rare or something, and it just straight up didn't work, and it was going to take a minute for it to load if like the average person like tried to open that on their phone. So for a 3D work, I recommended that she got that down to like 20 or 25 megabytes. And that is kind of in the range where marketplaces tend to be happy with it. Yeah, I think yeah, some of them are probably getting better. Again, some of my data is a bit old. Let's see. Yep, as people are saying, it's about so Etherscan. If we look, Etherscan is really handy to know how to browse through, because it's just like often if somebody's UI breaks, and you really want to learn something about a smart contract, is like you can go in and interact with it through the Etherscan UI. So I'm using nouns because like I've been just playing around with their contracts a lot recently, which is why they're top of my mind. So here's like a UI where people can bid on a noun. But also, if I like go to the like auction contract over here, even if I didn't see that UI, I can actually see the behavior of people interacting with this contract. And so I saw that somebody placed a 7 ETH bid. I can see that exact same thing on the Etherscan UI. And Etherscan even like makes it so that you, if it's like a standard method that they know how to interpret, it'll even show you it here on these like methods. And so it's just super handy for if you're trying to just like look at, okay, what's happening with my auction contract, or like what's happening with people transferring my tokens, then like Etherscan rather than your own UI is often a handy place to look for that, because I can just see token IDs are being transferred around. I can look at you can even look if you're curious about like the distribution of holders of like your things, you can just click holders, and you'll get this like pie chart of like who owns what tokens. This is all possible because NFTs all use the same kind of standard smart contract interfaces. So I think like the ability to just navigate Etherscan and look for this stuff is quite useful. People often upload their code as well. So if you're like, how did they add that feature to their project? It is a good practice within smart contract development to upload your code so that others can know what they're interacting with. And so if you were like, how does nouns create their SVG files? You can like straight up go here, look for the token URI function, and see how they're doing that. So this is just a very useful knowledge to have if you're maybe trying to get inspiration for how your own smart contract could work. If you're thinking about like, hey, this platform wants me to use their smart contracts, but I don't know, do they have a button that they haven't talked about publicly that allows them to take down my art or delist me or take all my money? Like, knowing how to read the smart contracts will help you understand if any of that stuff is going on in the background. All right. We talk about omni-chain mints, like zero layer, where you can mint on ETH and move to Sol. So I don't know the specifics of how they've implemented it, but to me, the only way this is possible is if there's something called a bridge. Typically, what a bridge between blockchains functions like if you have an asset on one chain and you want to move it to another chain, you have to like lock it up or destroy it on one chain and then create it on the other chain. If that makes sense. And then if you want to bring it back, you destroy it on that chain and bring it back to the first chain.
So you basically, hi Isaac, Yuri here. I made the question. So you basically have, you create one smart contract in Ethereum, and then you have another smart contract in each chain, right? And then you make this.
Yeah,
bridge.
that's exactly right. But then the question is, like,
Yeah.
who does that destroying and who does that minting and destroying? Oh, go ahead.
Yeah, I saw, for example, the Damien Hirst. It's not layer zero, this same thing, but they had this burn crash. So you move the thing from Palm to open to Ethereum and then back again. So you had to burn it. But so I'm curious, like, I'm not sure how this the layer zero goes, but once you there needs to be something that connects one chain, like the burning from, if you mint it, you have it in Ethereum and you want to burn it in Ethereum, and how does it appear? How does Ethereum talk to Solana, for example? Is this
right? That's the question. Is like how, and the answer is that somebody has to sit in the middle. So if like this is Ethereum, and like this is Solana. These don't have a channel in between them, and so you have to have somebody that's operating this like bridge, and it can be like maybe it's like a decentralized network of people doing it and stuff, but you as somebody that has a you as somebody that has like your NFT over here, and you like request to the bridge to move it over to the other chain, then for NFTs, like it's kind of hard to make like a general purpose. It's kind of hard to make a general purpose one, but generally there's going to be a smart contract on both chains where it's like, okay, I want to bridge it. The original token probably still exists, or it at least like is like locked up into this thing. And so you can think of it existing on both chains. And when the bridge says, okay, unlock it, that's when like you can take it out and spend it. And then if you were to move it back, it would kind of go in here, and then the bridge would say, okay, unlock it. And so you kind of have to like, that bridge in the middle is the thing that probably layer zero is also doing. These systems are cool, but the problem is every time you see in the news that a blockchain was exploited for $200 million, $1 billion, it's usually the bridges, because these bridges are the ones who are like holding all the assets on both sides of the chains. And so if somebody figures out a way to tell the bridge to unlock, then, oh, look, now they're unlocked on both chains, and people think this one's worthless now because the original one is now unlocked and stolen. So like bridges and doing multi-chain stuff is super tricky for that reason. Will there be a bridge regarding the ETH merge? So with the ETH merge, like we have, all right, let's do another diagram where like here's all like the Ethereum blocks, whereas like, you know, this is block number 1,000, like block number 1,001, and like each one of these have like a bunch of transactions in them, and then we also have kind of like the ledger where it's like, okay, who owns what on the blockchain. At the merge, what's going to happen is like it's probably 80-90% of people will say, okay, now we're going to everyone on Ethereum, we're using this new blockchain, and this is like the merged, like the proof of stake blockchain. And over here is like the proof of work blockchain. So at the point when the merge happens, all of the people that you like say, okay, hey, what's the Ethereum chain? If they agree with the merge, then like now they're gonna start returning you data about here. But there's nothing like forcing this chain to stop working. So there's probably going to be some people that are still like, oh no, we like this chain, and so they're going to start generating stuff as well. And so this is called a fork. And so this means that if you had an NFT on this chain, the merge happens. You have it on this chain because like they're using the same memory, but then technically you still also have it over here on this chain. And like there's varying degrees of I guess you would call it legitimacy or validity on this chain, where some people might be like, oh yeah, that chain, it's illegitimate. Yes, technically your assets exist there, but we don't believe in it. But like that's kind of the thing about blockchains, is like they can fork in this way. So like way earlier in Ethereum's life, there was a fork that created the ETH Classic chain. And that chain still exists. And ETH on that chain is worth like, I don't know, like $40 now versus ETH on the main chain, which is worth like 2,000. So it's not worthless. In fact, like some people are still like, no, this is the real one that we should be using. And so when the merge happens, it's actually going to generate the same asset on both the forked, both the original chain and the new one. And if you decide that this is the chain you want to use, which is like highly risky, probably don't want to do that at all, your asset will just now be, it's like there's two of them when there used to be one of them. So this is all kind of weird because like back when the fork happened in 2015 or 2016, there wasn't really a whole lot of on-chain art. So there wasn't this case of like all of the art got duplicated. But now there's so many NFTs out there. I mean, this is an unanswered question. Like what's going to happen if this fork stays alive, but now there's like, you have your NFT on both chains? Most people are going to tell you, ignore this one, it's not legitimate. But who knows, maybe it becomes something that people find interesting someday.
Can I just ask a second question to that one there? I'm so sorry.
No, go ahead.
So with the fork that, you know, the argue of legitimacy, it doesn't lock it the same way there's a bridge. So if you're making one of one, suddenly immediately it's a two of two? Or, okay, thank you for clearing that up.
Yeah, technically there's both. I mean, forks happen every day, but then they often like remerge. That's called like a chain reorganization, where like just because the world is big and it takes non-insignificant amounts of time for data to get around the world from like the US to Asia. Like there could be this there could be this network in the US that are like thinking, oh yeah, we're chugging along, this is our blockchain. And then suddenly they realize that like, oh crap, we diverged. Because like the blockchain is trying to keep everybody's computers in sync all around the world. And you can imagine like if you got like temporarily desynced, then like there are two different states and then they get merged back together. A network fork is when they don't get merged back together because people say like, we think that our chain is legitimate. And so so that's why it kind of duplicates assets rather than like, that's why a fork is different from like a bridge.
Thank you very much.
Yeah, I'm interested to see what happens there.
Hey, this is Laya here. I'm sorry to interrupt. I had a question. So when there's a fork, will there be another copy of the IPFS, like for one asset, or it's just the same IPFS connected to another fork?
Same IPFS link. So the data stays the same. Unless, like, what if maybe you have a feature of your NFT that allows you to update the artwork? If you update it on one, it doesn't update on the other because like they don't talk to each other. And this might be maybe we don't want to go down this path. But I think that this actually won't happen. I think most people will think that like the legitimate chain is this one. But yeah, it won't change anything off chain. Like it won't affect like your hosting or anything like that.
So there is only one data. We're not replicating the data. It's just the
It depends if the data is on chain or not. If you use IPFS, then it's just a link to your data on chain. And if you're like nouns and have your data on chain, then it's actually going to have now the data exists on both chains.
That makes sense. Thank you.
Let's see. So we talked about a lot of this stuff. So like, what actually is an ERC 721 smart contract? Like, it's really just a collection of methods that your smart contract has. So if I go back to the noun token and I click read, a lot of this stuff is additional features that they've added onto the core standard. But the only stuff that is actually important for OpenSea or Rarible or anybody to like know how to render it is this like owner of, so dysfunction, the name, which actually tells you the name of the collection, the symbol, and let's see, token URI, which was not working earlier. I'm really confused why this is broken. Okay, no idea why that's broken. So there's some of these functions are like core to what an NFT is, but there's nothing stopping you from adding whatever additional features that you want onto it. If you want an NFT to, like here, just some ideas that I have are like, if you want the content to actually change every time it's transferred, you can do that. If you want to change the content, like depending on the day of the week, you can do that. If you want to change the content based on which wallet it's sitting in, like that's also possible. If you want to like make the token duplicate itself every time it's transferred, you can also do that, where it's like, if I transfer this, it's actually going to generate a copy, I'm keeping one and I'm sending you one. Like you can override anything you want in these smart contracts to add something for your own experience. The cool thing is like, this just means that there's so much more freedom than just like I'm putting an image on chain. You can think like, how do I want my art to respond when people interact with it? Like that to me is like the cool thing about why you should learn a bit more about like the smart contracts, so that you can like start really embedding the art with the medium in addition to like thinking of it as just a place to display your art. So one quick plug, if you do want to learn about like how to just code smart contracts, this website is really useful. It's a free service that Austin Griffith runs called Speedrun Ethereum, and the first example is actually an NFT example where you'll just be editing some code and seeing how that like changes things. So yeah, Speedrun Ethereum is like if you are feeling inspired some weekend to just, I'm going to learn how to code this weekend, you can go from zero to being a smart contract developer pretty quick. Cool. That's kind of the end of my prepared content, and I actually have a development environment open with an NFT smart contract. Yeah, I think I also started with Crypto Zombies. I think that was my first ever project years ago. So, good question on, is it hard to code a simple smart contract? So, this is a development environment called Remix, which like you don't even have to download anything onto your computer. But like if you go to remix.ethereum.org, you can just start coding stuff right away. So there's a lot of code on my screen, but pretty much all of it is copy pasted. Like this is all the code you get if you use like an open source NFT template. And then all of my code at the end, which is making this like my NFT project, is these like 12 lines. Yes, so creating a smart contract without knowing code, like coding is important to know. Manifold is super handy for deploying your own contracts with like different flavors. And they've actually also started adding like apps and stuff to it too, which is like super handy. So if you want to like get the benefits of editing the features of your smart contract without knowing code, then things like Manifold are quite handy, because like they'll say, hey, what features do you want? And then in the background, like it's just piecing together a few different templates. But what's good to know how to do is like, I'm just going to start with the absolute basics and code an NFT smart contract. So I'm actually going to remove this stuff. Oh yeah, this is. I'll zoom in a little bit. These lines from like line 1020 to like 1040. This is an entire NFT contract. So what I've actually done here is I've said my NFT is ERC721. So the is word is saying that like this thing that I'm doing is going to import all of this code above it. You should at some point in your smart contract development journey, you should read every single line of this code and understand what it does, but you don't have to from the start. All I have to do is say my contract is this, and that is word is like a code is like a term in programming where it's like it's an implementation of this above code, but it also means that like now I'm going to add my additional functionality on top of it. Looks like I see a question. So when minting an NFT collection, what are the benefits of creating your own smart contract versus being directly on a marketplace like Foundation? So if you have your own smart contract, one is definitely like the sovereignty, but there's also there's like risk in using somebody else's smart contract if you haven't read every single line of code. Like I don't know any marketplace that actually has this, but it would be easy for me to add a function where like, let's imagine that this NFT collection is actually like, my NFT marketplace contract. I can add a function called steal, and I can make it, and I can just put in the token ID. And now I can have a feature that says like transfer or like safe transfer from, or no, let's say transfer token ID 1 to me. And I could restrict this so that only I can call this. But like just these 3 lines would make it so that I could you could be using my NFT collection, but I can go in and just take the token from whoever holds it. A marketplace probably would not add this function because nobody would use it, because like anybody could see that this code is on there. They could call the steal button and be like, what the hell, you guys are using like a totally like vulnerable collection that other people should not be using. But you can imagine that like maybe it's not an on purpose thing, like maybe it's a bug that that's in that collection that you weren't aware of, or maybe it's like an admin, like there's actually a function that you'll find in contracts is called pause. And what this actually does is it disables all transfers and sales. And programmers will put this into the collection in case somebody discovers a bug and they want to pause the contract while they figure out, okay, how do I fix this bug? So not necessarily a bad thing, not necessarily malicious, but let's imagine that like the marketplace for some reason didn't like you and they wanted to pause. Maybe they have the ability, like OpenSea or Foundation or somebody, I don't know if they do, but like maybe they have the ability to like pause NFTs created by you. That is not impossible. Like I would actually be surprised if they don't have that functionality. So if it's more than just the desire to own your own contract and stuff, you also are giving up certain amounts of control if you're just minting on somebody's website versus actually creating your own smart contract. And there have been some issues with like OpenSea and other collections where like there was a thing left open and allowed people to actually what happened on OpenSea, I'm pretty sure was like if I submitted a bid to purchase your thing, and then it got transferred around, even though the UI wasn't showing my bid anymore, that offer was still valid, and somebody could like take that and fill the order. And so I don't remember exactly how it got exploited, but I guess you could imagine that there's an NFT that's trading for 10 ETH or something, and I place a bid to buy it for 9, and it doesn't get filled, and then the price, it gets transferred around, and then the price drops down to like 2. My offer to buy it for 9 is still technically valid. I don't think that's exactly how the issue that they had, but that's like a potential thing you should think about.
I think it was a bit different. It was, you list it for sale for 9 ETH, for example, and then you move it to your hardware wallet or something else, and then when you move it back to that wallet, that 9 ETH sale comes back.
Oh right, yeah.
So people could list. So you couldn't. It didn't unlist the sale once you moved it to another wallet. So people could like just transfer back for the hardware, from the hardware wallet to hot wallet to sell, and the price was like 50, but it just activates the 9 ETH.
Right. Yeah, that makes sense. So what's funny is like if we look at so Dada, like some friends that they created some very early like pre-NFT standards crypto art. If we read their contract, if you transfer, the cool thing, again, this is all open source code, so like that's the cool thing about this is like when you do transfer, look at line 372. It calls a function called make collectible unavailable to sale. And so like that's kind of like a fun thing is like if you know how to read these contracts, you can detect like I now feel confident that if I'm using this, that bug would not happen to me, because when things are transferred, it also like delists them from their marketplace. So like useful reasons of knowing why to like kind of dig through code. Nice. And actually, this was fun and interactive, so I don't have a whole lot of time left for live coding because unfortunately I have something starting at 2 Eastern. But if you guys have any ideas just kind of come to mind for you, like now that you are thinking about like the programmability of these collections, like are there any features that you would love to see implemented that I can just like tell you, yes, that'd be easy, or no, that's impossible?
Hi, this is Laila. I guess something that is always interesting me is changes on the artwork, the weather patterns or changes in the stock market. I've seen artwork done that before, and I'm always interested how do they do it? Can it be done here?
Yeah. So when an NFT, the way that you know what it looks like was that token URI function, and so I can so inside of this contract, I can have a function, or like a mapping, like token URIs, and then I can take like the transfer function, and I can override the, or actually, inside of NFT contracts, there's a nice utility function called before token transfer, and so what I can do is inside of before token transfer, I could do token URIs for the token currently being transferred. Actually, this would need to be square brackets. Equals, something new. So this one line of code, this is not fully functional by itself, but like you can take this before token transfer function and add your own functionality where it's like, okay, who is it being transferred to? If it's being transferred to this person, I want it to look like this. So like you can add that line of code to before token transfer, so that like when it gets transferred, you can respond to that change before it happens.
Oh, thank you. That's I'm really interested in doing something like that.
Cool. This is actually
Thanks for today. Yeah.
Yeah, of course. This is also the place in the smart contract where if you wanted to make it so that a token like was not transferable unless it was like under certain conditions, this is where you could also like throw an error and be like, nope, sorry, we're not going to allow you to transfer me. Like you can do all sorts of weird stuff. Let's see. I see a question about crypto native and formatted poetry. So yeah, I had a couple examples. So I did this. It was like this project that I tried to do. God, I wonder if it's still on my GitHub. I wanted to make like a Mad Libs style thing where like it would create like SVGs. Maybe it would create SVGs of words and with a blank in them and allow the owner of the token to like fill in the blank with another word, and then that would update how it gets rendered. How did I sent it to this one person. Okay, I won't try to find it now. I'll try to find it after. But yeah, so you can create an SVG. This is how actually loot works. I would look up the loot. I would look at the loot code. Loot project contracts. So I don't know exactly where it is within. This might not even be the right repo. Actually, let's try to find this. This will be cool.
I'm curious, have people done other forms of files besides SVG crypto native? Like, I'd be interested in like a non-graphical, like one that's like an RTF or an HTML or even TXT file.
HTML, yes. In fact, I'm pretty sure OpenSea has a tutorial on how to do HTML NFTs. Or maybe I've read this. Yeah, embeds. Or like, yeah, if you look up like HTML NFTs, then like it's actually interactive. Like you can make a game that way.
Would that be crypto native or would that be on IPFS?
Nope, that'd be crypto native. So it would actually be storing the code to generate your HTML on chain. You could do it both ways. You could have it stored off chain, but like you could. It might be a little expensive, but you could. The way that the loot tokens work, and wow, they've gotten a lot cheaper. Let's go to Loot's smart contract and look up token URI for like token 1. Oh, perfect. So here is the loot. Here is the loot code. So I can take this, go to base64 decode, and then actually it's a little bit annoying. You grab this, and then decode this, and now here's just SVG. Like you could also make this HTML. So this data is all on chain, and it's basically gluing all of this stuff together to get you this image.
Right.
So you could do the exact same thing with HTML tags. The problem with doing TXT is you wouldn't be able to add emphasis because TXT doesn't have any markdown support. But you could do markdown, you could do RTF, you could do HTML, you could do SVG, and then you could like even dynamically change the emphasis by like adding in a class of like bold or something right into it.
Cool, thank you.
Mm-hmm. See. NFTs that can make NFTs. How would that technically work? So the main NFT. So there's this cool thing that I linked to here, which is called Loogies from Austin Griffith. Let's see. Or where is the? All right, this is an example of an NFT that owns another NFT. The NFT of the tank owns 3 SVG NFTs of these loogies, and it's floating around inside of it because like they were actually transferred. The ownership of one NFT was transferred to another NFT. So it's this like kind of weird system that you can create where this tank is actually owning other NFTs and rendering them inside of itself. And I don't think that this is how like mocha floors work, but my idea for I would love if they did. I have to ask them. But like they have these like different rooms, and like the gallery itself is an NFT, and then you can like display your NFTs on their walls. You could create a version of this that actually the gallery owns the tokens that you're displaying in the gallery. Which, again, it might work that way. I'm just not sure. Haven't read the code. Always read the code. All right, so I do have to end abruptly. Sorry for ending a little, I think, earlier than the calendar is scheduled, but hope that this was fun and useful and inspiring for some on-chain creativity.